once we
On the eve of a very, very big rocket launch, satellite launch, and really a big day for the Weather Enterprise tomorrow as we launch our second of 4 weather satellites that NOAA is planning to launch in the upcoming years to kind of continue the GOES constellation and keep it going, help to give us reliable satellite data over the next couple of years, and improve our forecast and warnings. We've got a great expert tonight, satellite expert Jim Yo from NOAA joins us. We appreciate you coming on. Sorry for some of the tech difficulties we had at the start there, but glad we could get you on.
Hey, glad to be here.
And so we launched GOES-R, about a year and a half ago now. Give us just kind of your thoughts on where we've come since then.
Well, the launch of GOES-R was really exciting. I guess now I tend to think of it as GOES-16 now that's in a geo orbit and it's operational. We really have been impressed by what's occurred. That is, you have high hopes when you put new technology into space, and all the things our expectations have come to fruition. We've really benefited from having the advanced baseline imager providing us greater detail with 4 times the resolution, 3 times as many spectral channels that help us identify features in the atmosphere and on the land and ocean surfaces better. And then finally having 5 times the scan rates that we're refreshing our imagery 5 times more quickly. All those things have really borne a lot of fruition, even from the very early test phases, forecasters in the field, and even out to the general public. People were really reacting positively to those, not just for the wow factor, but for the benefits they were able to provide in terms of making better forecasts, and that in turn enabling people to make better decisions and better plans in order to protect their lives and properties, or simply to plan their activities more effectively.
And so GOES kind of got its, I guess, trial run when it was in its preliminary pre-operational test phase over the summer. But some of that data was used operationally in many forecast offices to kind of help warn. Give us some examples of where the GOES-R satellite has really just proven its worth over the past year.
I can give you a couple. One of the most significant ones in terms of lives saved, or at least lives moved out of harm's way, was when Hurricane Harvey made landfall near Corpus Christi. Of course, that was a huge system dumping a lot of rain and heavy winds on top of, of course, with the hurricane. We were able to track the motion of the eye so closely with using GOES-16 that FEMA was able to send people out during the eye passage in Corpus Christi and move people to safer locations before the back end of the storm hit, roughly about 200 people. So there's a very dramatic example. On the other end of the spectrum, there was an event in the fall where the airport in San Francisco was socked in by heavy fog. Big surprise, for San Francisco. But this did cause a closure of the airport. No flights could take off or land. The forecast was not favorable for that fog dissipating. However, using the imagery from the ABI with that rapid refresh and the fine detail, it was clear that the fog was dissipating more rapidly than forecast, and so that closure was lifted earlier than expected. This allowed 32 planes to land on schedule that otherwise would have been diverted. The airlines say they saved about $100,000 in fuel. I don't know, if you're an air traveler, just the aggravation of being diverted, being one passenger on any one of those planes, let alone all the passengers on 32 of them, you think this is a huge thing in terms of keeping your plans intact, as well as avoiding other expenses being incurred.
And so now we're getting ready to launch GOES-S, which is going to cover the West Coast and the Pacific Ocean. With GOES-R and GOES-16, one of the things I noticed is that even on the western periphery, kind of that, I guess, the edge of the satellite view towards portions of Washington, when it was centered over the United States, we were still getting excellent imagery, even on the fringes. Is that just part of the higher resolution data?
Well, that's part of the nature of scanning from geostationary, and also having, as you say, the high resolution, very good pointing knowledge of the advanced baseline imager. A big deal, though, from my perspective, when we have this two-part constellation with GOES R, GOES S, or GOES 16, GOES 17, however you prefer to refer to them, is we'll have double coverage over most of the continental United States. So we'll be able to see our where we live with both of those satellites. But we'll be having coverage to the east as far as the west coast of Africa coming from GOES 16 or GOES East, as far west as New Zealand from GOES West. So it's the weather that we experience where we live doesn't originate where we are. As an example with hurricanes, of course, those originate as waves off the west coast of Africa that deepen into tropical depressions and storms and hurricanes. And of course, a lot of the winter weather we see, not just on the west coast, but indeed coming across the entire U.S., is really originating out over the Pacific Ocean. Um, and even though we think of GOES as being kind of the sentinel that gives us, that really enhances our short term warnings and forecasts, we use it in our longer term global numerical weather prediction models as well. We'll be looking at winds that are derived from the GOES West imagery and feeding those into our weather models. And that again will be impacting forecast well into the future, 3, 5, and 7 days for the continental U.S.
That's one of the things I always try to stress to our viewers. We're here in the Appalachian Mountain Range, and a lot of times we'll get that energy moving through the Pacific Ocean and coming ashore there towards portions of Washington State. And I stress there's not a whole lot of ground observation stations out in the middle of the Pacific Ocean. But with GOES now, it's going to be awesome to have that higher resolution data, more frequent data, be able to just show it visually, and some of the short waves and energy coming ashore.
No, absolutely. I mean, this is a big deal, and of course, in California where they're looking at rainy season, the Pineapple Express storms that come from Hawaii and whatnot, and they're interested in those whether it's raining or not. They're because they've been experiencing a lot of drought and water shortages, so they're looking at that very closely. Another thing that happens in the western part of the U.S. is this the the image we're getting now with the added channels allows us to spot and to detect wildfires more rapidly during the fire season. Actually, last year, in some cases, it was actually satellite forecasters who were spotting the onset of wildfires before local on the ground reports were being made. So this is helping get firefighters into respond to fires more rapidly before they became larger fires that required more resources to put out or contain.
Talk about the mesoscale sectors for a moment. I understand that once both satellites are operational, we're going to have four sectors, right? Are those going to be able to be moved around? Uh,
Yeah, that's absolutely the case. Um, each of the two GOES satellites will be able to scan two sectors simultaneously with 1 minute resolution. You can actually better that if, for example, from GOES 16 right now, you could target an area, the same area twice, but offset them by 30 seconds, so that effectively you achieve 30-second resolution for something that evolving extremely rapidly. So again, you would be able to have four such sectors with 1 minute resolution when over the CONUS, for example, when or in points beyond, with the full constellation in place, and that'll be really exciting. Certainly, in an active hurricane season, you can envision having more than one storm that you'd like to sample rapidly. One that's impacting the coast, and another that's developing. Uh, there's nothing that says you won't have a fire event or in the west coast or something like that at the same time that you're having an east coast hurricane. So we do have a protocol for to determine when and where we'll do these rapid scans. I can envision there will be some competition for those from time to time. We even have one concern. I'm smiling because we talked about this today. We were hoping we could do rapid scans over Cape Canaveral from GOES R to support the GOES S launch, but there's some critical weather in the central United States, which I think has precluded that.
Sorry, Shay, you can't get a sector scanner of your house for tomorrow.
Well, that does lead us to a question that we asked each other before the show is going into the launch, looking at the weather in Florida, it looks like it could be a little bit windy down there tomorrow, maybe from the west southwest or maybe a little bit of an offshore wind. Talk about the criteria for being able to launch on time at 5:02 p.m. Is there what's the wind threshold and what's the weather threshold that would maybe stall or set it back on its time?
Well, let me give you the short answer. We look good in that regard. I had the good fortune of sitting on a panel with some folks who were more expert in the launch details than I am this afternoon. They told me that with our launch vehicle, we can really, and fully loaded like this, we can withstand low level winds of up to 35 knots, and we're expecting winds that are no worse, no greater than 15 to 20 knots tomorrow at 5 p.m. and probably tapering off some after that. Of course, a bigger concern would be upper level winds, and the wind shear that would be associated with them. But we're well south of the jet stream right now, so we don't anticipate any problem in that regard. So it looks like for tomorrow at least, the wind loading shouldn't be a factor for launch.
How much do NASA and NOAA kind of work together in the final days before a launch? How much is that partnership still going on even up to launch day?
Oh, it's very very tightly. We're very much tightly linked at this point. Now, I wouldn't want to rule out, of course, the linkage with our private sector partners. With Lockheed Martin doing the launch, for example. Um, it's everyone is very focused on their own part of the mission and on the launch getting us there. But everyone is very concerned about what's going on in an integrated fashion as well. And of course, for over the life of the program, the linkage is extremely tight.
Just thinking back to some of the first GOES rockets, we were talking about this earlier. Do you think when they launched the first GOES, they ever even envisioned what we have today?
I've often asked myself about that. I wonder what they really were thinking. That what they expected to get out of it. I mean, sometimes I look back at some of the early images, not just from GOES, but from the first Tiro satellite in 1960, and to someone who's watching um, weather broadcast on television today and seeing the imagery, you might look at it and say, "Boy, that was really unimpressive." But I'm sure to the people who were looking at that time, and then when I was a kid, I was looking at that. I was certainly impressed by it. So I think we've certainly met our expectations, but typically exceeded them, both in the quality of what we were able to produce in space, but also in how we've been able to apply it more and more successfully, both to research meteorology or environmental science, and ultimately, most importantly to me, to operational forecasting to support public safety and public decision making.
Gary, I think it was you and I were talking earlier, kind of saying where do we go from here? What's the next step after GOES 16, 17, 18, 19? Give us your dream view, I guess, of what satellites could become.
I'm kind of like Jim was saying. I mean, I grew up in the same era he did when the first satellite pictures came down, and it's like, wow, that's pretty impressive. And then you look at today, but it's kind of like television sets. You think about TVs and how much they've improved, and you just can't imagine them improving anymore. And actually, Jim, that's what I wanted to ask you. Is there actually any difference between the GOES 16 and GOES 17? Are they identical satellites, or is there anything that's been tweaked out a little bit more with the 17 that you've learned with the 16?
Well, we fixed certain mistakes from the point of view of what we think of as of uh, a neutral atmosphere weather. We're really identical. The only thing is we've seen this promise fulfilled, or come to realization with GOES 16 and GOES East, and now we're going to see that expanded to cover the entire hemisphere when we get GOES 17 up. But there are lessons learned incorporated. Uh, the GOES R series does include force sensors for solar and space weather monitoring. So because space weather being a part of the NOAA mission as well, providing warnings and forecast of solar storms and the downstream effects in the Earth environment. One of those instruments is a magnetometer. The magnetometer itself is fine. The design of that, it met specification as built. One thing that happened on GOES 16 is apparently there's a source of magnetism that's too close to the magnetometer, so there's a lot of work trying to clean that up. Somebody said once, so you can mill chaff, but you can't make wheat out of it, and it's the same thing. You can't make signal out of noise entirely. Well, but where the lessons learned have come into that is they've worked really hard in the integration of that magnetometer on GOES S that's going up tomorrow to avoid having any onboard sources of magnetism that affect that.
I'm glad you brought that up because that was going to be one of my questions. With having two of these space weather sensors up now, what was the GOES 17 satellite going to be used for that GOES 16 wasn't going to be used for, I guess, in space weather monitoring?
Right. That's one place where that will come into play. But of course, having more, from the point of view of space weather, you're always trying to have coverage of the full, how do I say this? And not Earth-centered, but in sun-centered coordinates. Having two of them gives you a fuller view of the magnetic environment and the space environment around the Earth. So even if both were working perfectly, you'd get a better view. And of course, with having the magnetometer working better on GOES 17 is going to be an improvement for us.
This is kind of a random question, but I know NOAA does a lot of the space weather forecasting stuff, but does NASA do any of it as well? And if so, can NASA request to look at something specifically to NOAA?
Well, NASA does look at the data routinely. In fact, NASA has a very strong research component in space weather that's centered at Goddard Space Flight Center. Sorry, it's been a long day here, but a lot of interviews outside of Washington. NOAA has the operational space weather prediction requirement, and that's done by the Space Weather Prediction Center out in Boulder, Colorado.
Gotcha. Let's talk about the Pacific Ocean, that big, vast open ocean.
I'm for it, yeah.
Some of the advantages GOES is going to offer for maybe shipping or hurricane monitoring, even Hawaii, and just hanging out there in the middle of nowhere, quote unquote. They're going to be able to see a lot more things that are going to impact them.
Absolutely, and I can tell you that the Western and Pacific regions of the Weather Service have been a little jealous here for the last few months since GOES 16 became GOES East, and I think they're feeling a lot better served with the coming of GOES 17 to become GOES West out there. But you've hit on exactly all the points there. There's not over any of the oceans. There's really not sufficient coverage. Simply because you can't have ground-based radars out there providing the kind of coverage we have over the continental U.S. We don't have routine radiosonde launches except from a few islands that are very sparse. So we really rely on satellite data and some ship reports and aircraft reports over the main air routes for the Pacific. And the Pacific is hugely important because it's the biggest, warmest ocean. We talk a lot about hurricanes impacting the East Coast, but of course, we need this coverage to cover typhoons in the Pacific Basin as well. Not just the ones that impact Hawaii and American Samoa and the West Coast, but of course, we have commercial interests that go across the entire Pacific Basin. Air traffic is a big deal, and of course, over the continental U.S. again, we have radars that tell us where thunderstorms are. One of the really neat things that's going to come with the GOES R series is we'll not only have the finer imagery that shows us where thunderstorms are in much better detail in the imagery. You can see overshooting cloud tops, for example, that are indicative of really strong convection in the presence of thunderstorms. But in addition to that, you have the global lightning mapper that we haven't had a chance to talk about. The GLM is taking 500 frames per minute over it for both GOES 16 and eventually, of course, GOES 17, showing us exactly where the strongest thunderstorms are and collections of them. So we get a much better idea of where a system may be decaying, where it may be strengthening, where there's a likely outbreak for severe thunderstorms or even tornadoes, for example. This is a big deal for our Aviation Weather Center, which wants to route traffic, away from from those kinds of storms. Keep them away from the associated turbulence, so they have a much better idea of where that's going on. This is also a big opportunity for research meteorology, which I think will lead to better modeling in the future when we're able to look at that imagery and the overshooting tops, for example, in conjunction with the lightning maps. I think we'll be able to. We're going to learn a lot from that. That's going to play into the future of our severe storm weather forecasting.
I think the rest
To
of
follow.
our well,
Oh yeah. Sorry, Ricky. I'm just stumbling all over you. Follow up on the question about the Pacific. How is this going to help with ENSO monitoring and La Nina and El Nino conditions?
Well, one of the things we'll be able to do is we do have channels in the imager that are sensitive to variations in sea surface temperature. So of course that's a big factor for the southern oscillation. So we'll be using the GOES series for that. Of course, we combine those with the polar satellite data as well as with in situ measurements in order to do that monitoring and prediction. So I think what we'll certainly have we should have more accurate and more detailed maps there. I don't know if it'll give us it. I'm not really an expert in that, so it's hard to say for me to say how much lead time that'll give us more in prediction. But we'll certainly have better and clearer maps of that as it evolves.
Speaking of the Pacific, my question is overlap. So we have the goes east. We also have the Himawari 8, Himawari 9. It goes west. Where is that going to fit in between? Is there going to be some overlap between the two? Maybe some enhanced products out of it? And also the other part is how far north will this go? Will it also cover the Arctic and some of the areas that we need some more studies on?
So it'll get us to the edge of the Arctic. We'll have very good coverage for Alaska, which is heavily dependent on satellite data. In fact, in Alaska, because it is at such high latitudes and the polar satellites come over so much more frequently there than they do over, the mid latitudes in the continental United States. Frequently in Alaska, they kind of look at the polar satellites as fulfilling that sort of a role of being a constant watchdog in the sky that the rest of us look at or expect from GOES. But there's actually been a lot of excitement from at least earlier when GOES 16 was a little bit farther west from the Alaskan region. We really do extend far. Our coverage will extend as far north as Alaska, as far south as the tip of South America. And then I kind of almost forgot the first part of your question, Shay. So
I was asking about overlap with the GOES East satellite and Himawari 8 and 9 over on the Pacific side. So it looks like we're sort of getting the entire northern hemisphere covered.
Absolutely, and we do, of course, in the northern hemisphere and extending to the southern. But what's really happening with Himawari is, in GOES West, is we're able to get that coverage around the equator, extending farther and farther west and more seamlessly, which I think again is really important for all of us. We already use Himawari data in our numerical weather prediction models because again they're upstream from us for a lot of our weather, particularly in the winter. And that was the imager on Himawari, of course, is basically a copy of the ABI, very similar in the construction, the channel selection, and the type of resolution we see from it. So that was has been a great opportunity for us to see before the launch of GOES 16 what we could expect from the ABI on the GOES R series.
Now, Jim, you hit on something about Shay. You were through, right?
Yes, sir.
I didn't want to step on you, man. Jim, you hit on exactly what I'm kind of looking forward to too. GOES 16 wasn't operational during severe weather season last year, and the lightning detection capabilities. Really looking forward to see what the system can do. How exactly does GOES 16? How is it able to actually detect lightning way down here on the surface of the Earth?
Okay, this is actually another type of imager that's making actually 500 images per second. It's able to detect and discriminate. It can detect both cloud to cloud and cloud to ground lightning strikes, which of course, both of which are occurring in severe weather, but via different mechanisms. I'm not particularly adept in the knowledge of the internal workings of the lightning detector. I'm a little bit more of on the user end of it, but but we're certainly very excited to have that because, again, as we say, when you're looking for thunderstorms, what we have been dependent on in the U.S., in the continental U.S., for the last 30 years, very successfully, has been with the weather radar network. Of course, now that doesn't help you over again offshore, but another place where you have problems with it is in the western United States, where the radar coverage is often cut off by mountainous terrain. So this is going to be a really big deal, I think, for looking at detecting and following the evolution of convective weather, severe weather, and thunderstorms in the western U.S., where we aren't able to rely on radars the same way as we are in the central plains and points east.
Yeah, and I wanted to jump in and talk about that. So I'm actually from the Four Corners area of New Mexico, and there's absolutely no radar up there. So it would drive me nuts looking for thunderstorms and looking for storms on the radar when it looks clear. We don't have the radar up there. So I think that this is going to be very good for that area, especially, and other areas like that that are just, missing that radar coverage.
Absolutely. I'd given another example of that in sort of an unexpected area, an area that had been served well by radar, of course, was Puerto Rico until Hurricane Maria hit. And of course, the radar was knocked out. So at that point, having the GOES data, admittedly not as much the lightning data at that time, but the imagery, that became the only game in town. And that was really important, when there's nothing else. It was good. If you're going to have a substitute, have a really good one, and that's what we had for forecasting and monitoring in Puerto Rico when Hurricane Maria was impacting them.
Definitely.
I'd like to turn back for a minute back towards the launch and then the timeline going after that. With GOES-R, obviously we had a fairly lengthy checkout period. Being a brand new satellite, it was checked out over, I think it was just about over the longitude that Memphis is in here, about 89 degrees west.
That's right.
Is the GOES-S, when it goes up, I guess the checkout period and so forth is going to be shorter, and will it go straight into orbit in the GOES-West position, or is it going to do a maneuver like GOES-East did?
It will do a maneuver like GOES-East. It will go into a central location for a checkout period of about 6 months, roughly. It takes about 17 days actually to achieve geostationary orbit. And tomorrow you'll get up to that's called the geotransfer position, which gets you almost there, and then you start doing a series of maneuvers with the onboard, thrusters that boost you up to the geostationary orbit. It's good to have it over the central U.S. when it starts, just because that allows you to do validation and checkout with all of your the systems at your disposal. It'll be very closely overlap with GOES-East, GOES-16, for example. It will be partially overlapping with the current GOES-West, which is GOES-15, but also with all the ground-based instrumentation and everything. This it does take a while to turn on the instruments, so they're not up and running, of course, from the moment the satellites is launched. So now, having said that, even though it will not be at its operational position until roughly 6 months after launch, the data will be available to forecasters for evaluation and comparison. And that, I can tell you that evaluation and comparison quickly turned into use. All these examples that we've talked about collectively with the GOES-16 are indicative of that. So somewhere in about 6 months after launch, it'll be allowed to drift, or actually encouraged to drift, so that it's about as far west as California, but centered over the equator. And at that point, it will become GOES-West.
That was going to be my question, was when kind of a rough estimate of how much time before we start getting non-operational data into the products.
Right. And certainly from the point of eye candy, at least, I think we can expect to start seeing some preliminary select images, from the ABI, probably about 2 months after launch, sometime in May.
The countdown's already on.
Yeah, it's exciting. That's I think.
So I guess, are you down there for the launch now?
I am. This is going to be my first satellite launch. I have mixed feelings about it. I've never been to one. Every satellite I cared about has gone up successfully. So I hope I'm not, like messing with a good track record and spoiling the mojo. No, I feel a lot of confidence coming from the launch team, from the NASA people, and the Lockheed folks. The weather reports are good. The launch vehicle has an excellent history, and we have a large launch window. So, as someone explained, if you've got between 5 p.m. and 7 p.m., if somebody strays into the restricted area offshore, you actually have time to get them out of there, without losing the whole opportunity. So, um, I'm feeling good. I think we're going to get this thing up tomorrow.
Good old wayward boat on Twitter is always the demise of a lot of things. I had the opportunity to be down there for excuse me, for GOES-R, and it was actually an emotional experience because you put so much trust and hope into this rocket that's going to carry this satellite up, and when it actually happened, it was a nice moment. Where do you get to watch from?
I'm actually going to be at the press center
Okay.
at Kennedy, just to keep doing some interviews with NASA TV, particularly one right after launch. So I don't get the prime viewing location. This is a work mission for me, not a paid vacation. But hey, I'm excited all the same.
Well,
And that's the thing. I mean, getting satellites into space, getting people into space, that's a complicated thing. I mean, NASA makes it look easy. Elon Musk makes it look easy. But I know, Jim, you're going to be on pins and needles tomorrow.
Oh, absolutely. And you don't have to be right on site to be on pins and needles. So with the GOES-R launch, I was watching on closed circuit TV from the satellite operations facility in Suitland, Maryland, and I was on pins and needles there. It was, even just with and I didn't think I would be driving in through the rain and sleet on that afternoon, and far away from sunny Florida. But we were all you get in there and you're waiting for this, and you have a lot of your time and in energy. I mean, really a lot of your career invested in it, and you're looking forward to it making the remainder of your career, the work that you're going to do during your career, um, more meaningful and better. So yeah, it's big stakes, and we're excited, but that excitement has both the joyful part of it and also that the part that's just a little fretful.
Now, I got two questions real fast, guys, if you don't mind. Jim, what's the life expectancy on 16 and 17?
Yeah, these have a design life of basically 10 years with 5 years on orbit storage. Now that's my experience with the satellites is that they tend to outlive their design life, so that's pretty conservative there. So we'll have actually the GOES. What's the next sequence in the RST?
T and U, yeah.
Yeah, I have to go through the
I always have to
alphabet
sing it
like
too.
I'm back in grade school. I'm a numbers guy. What can I say? But the launch of GOES-T is planned for 2020. Now that doesn't mean it would become immediately operational. It would be put into that central location in an on-orbit storage, which accomplishes two things. That means it's ready to replace, presumably, GOES-R, being the older of the two, would be the one that would be taken out of service first. So those, you never really know how those things pan out. So it'd be there for very rapid uh, uh, replacement of either of the satellites that when one should fail or when one should just reach a point of aging where you feel it's more prudent to replace it. The other reason to put it in space, as I understand, is it's more economical to store a satellite in space on orbit than it is to store it, in a bay and try to keep it clean and all on Earth.
Yeah, that makes sense. And actually, I'm glad you mentioned T and U. Are there any plans to put any different instrumentation, make them better down the road?
T and U will have basically the same payloads. If we have lessons learned from S in addition to R, the magnetometer example I mentioned earlier being the biggest one I can think of so far. Certainly, modifications would be made into place, but these would be more, fixing problems or tweaking rather than radical redesigns. I know that the design phase for the GOES-R series actually began almost 20 years ago in 1999. I think the first metal was cut for sensors for the ABI starting in 2004. The first real satellite construction for GOES-R began about 2009 or 2010, and it was delivered 5 years after that. So it's a long lead time on all of these. So I guess pretty soon then you can say it's time for us to start thinking about what will be possible 20 years from now. What will our needs be? Because that should be the driver more. Before the technology, you say what's the mission you're trying to accomplish? What are the data and observations you need in order to accomplish those? Then you start thinking about what are the sensors I need, in any particular orbit in order to achieve that. So yeah, probably, that maybe that'll be one of the things I'll get to do here in my golden years, is to start looking towards, what are the requirements going to be, if not the solution for achieving them, but what are those requirements going to look like in 20 years?
Cool. Thank you.
I have a viewer question that came in from JP Calb asking, now that we're launching all these new ones, what's going to happen to like GOES 15 and 14? Where are those going to be placed?
Yeah, they're put into orbital storage as well. And what that means is that their sensors are turned off, but their lifeblood systems are kept on. Their brain stays on and their comm systems stay on, so we can monitor their health and safety and overall condition, and we can call them back into service, provided we have enough fuel to get them into the right position, so that they could become a backup. They could come in and fill if we were losing one of our primary operational ones. But again, we want to have our backups really be as capable. That is of the R series, ideally, as opposed to having ones from the old NOP series. We can use them. We've talked about sharing one of those and moving it into an orbit favored by the Air Force. We'd certainly be open to doing that as well. When they run out of fuel or almost out of fuel entirely, or when the sensors have degraded past the point of functioning, or maybe they're more likely their solar arrays and their batteries have degraded past functioning well. What you actually do with the geostationaries is you boost them into a slightly higher orbit, so they'll kind of be out of the geostationary place and just leave them up there indefinitely.
I heard one time that a lot of the old satellites get used for kind of Air Force missions or communications missions. Is that true, or they're kind of repurposed?
They are repurposed, and we've certainly lent or sent some to other countries. We in the past, I think GOES 12 was moved to provide better coverage for Brazil, for example.
Okay. We had a question too. If something doesn't launch tomorrow, the backup date, and which I understand is Friday, in case for a weather hold or something like that, right?
Right.
Okay. We're not hoping for that, but it's there.
No, we're not hoping for that. And I'm not sure what happens if we don't launch on Friday. I have to go home on Saturday.
Yeah.
So, the honeydew list gets longer and longer. She's not going to put up with my absence too long, no matter how exciting this is. But
that's for ULA and the range to decide, I guess. So.
Exactly.
All righty. Well, I'll open up the floor to any of the panel members. I think Shay, do you have something? Or
actually, that was answered. Somebody asked about what happens to the old satellites, and he says that they stay in storage, space storage. So I think I'll pass that on to Eric. Eric had something with COD.
Yeah, I just thought I'd kind of chime in with here at the end, because I'm sure a lot of people are wondering, okay, so where can I view all this great data that's coming down? One of my favorite places to view it is the College of DuPage weather viewer. You can go to weather.cod.edu and search for the satellite and radar there. They got a really, really nice viewing capabilities there, lots of zooms, and you can look at the meso data every minute when it comes in, change your channels and product descriptions, the whole thing really nice. But they announced today that they released a major update to that. And it includes things like adding your own mapping overlays, data overlays like watches and warnings, radar, surface data. You could toggle on and off the GLM lightning mapper data. Lots of really cool things in there. They create animated GIFs. So if you're looking for a place to go and actually view this data, you can check out the College of DuPage. Plug for them. Yeah, but definitely check it out. It's excellent. And the upgrade is great too.
Now I'm going to have to check that out. That sounds like fun.
All righty. Well, thank you so much, Jim, for joining us tonight. We hope everything goes smoothly tomorrow. You enjoy the launch and can actually enjoy it for when it goes up before you're bombarded by media. being one of
No,
those.
it's going to be fun. The whole thing will be fun, and this has been an absolute pleasure. It's been fun to talk to this panel with so much engagement and so many great questions.
Well, we're all excited and looking forward to it. I've got my alarm set to tune into NASA TV tomorrow, and we'll watch it all together. And James wanted me to mention that you can watch our coverage of the launch right here on our YouTube, or not YouTube, our Facebook channel. James will be taking care of that, and then you guys can watch it right here on our Facebook channel tomorrow.
Yeah, and while we're trading links, can I just point out the Twitter feed at NOAA Satellites? That's a good one, just not only for information about the launch, but about GOES-R and GOES-S and all of the NOAA satellites.
Sure, I'm sorry. We usually give our guests an opportunity to plug any social media outlets they want to. It's been a crazy day. I forgot to.
I just fought for it.
Hey, that's all right. It worked. So thanks again for joining us. We've got some great upcoming shows in the next couple of weeks as well. You can get information on that on our website or by staying tuned to our social media channels. And we will see everyone here next week for another edition of the Carolina Weather Group Weather Podcast. And we're clear.
That's a wrap. Awesome.
All right.
There's only one cargo ship designed to transport rockets for United Launch Alliance. And tonight, it's pulling into Port Canaveral with the robust flight hardware of an Atlas V.
We're a high-tech vessel, high maneuverability. We have to be because we get into some tight areas on shallow rivers. The Delta Mariner is unique. It has 2 aft Z drives coupled by computer with the bow thrusters that turns 360 degrees on demand.
This crew has work to do. In less than 4 weeks, the rocket must be safely delivered, inspected, and assembled in order to successfully launch NOAA's highly advanced GOES-S weather satellite.
I sense from the crew the pride being part of this mission. And when I put this vessel alongside the dock, it is a very accomplished feeling that we all have.
The arrival of the Mariner is the start of operations for the flow of a rocket.
Teams from ULA and NASA's Launch Services Program start by unchaining the Atlas V booster and Centaur components, wasting no time in developing a plan and getting organized for transport.
We're going to take the booster over to the ASOC. It's going to be Convoy 1 to be the leader, followed by the booster.
It's a very exciting day for the vehicle system engineers as we're offloading the launch vehicle that will carry the GOES-S satellite.
Here comes the Centaur second stage, with its pressurized stainless steel tank as thin as a dime. Unable to support its own weight until fully fueled, it's carried off the ship by a specialized trailer. Next comes the Atlas V booster, all 106 feet of it. This booster and 4 solid rocket motors have one job: provide enough energy at liftoff for the entire launch vehicle and payload to overcome the pull of Earth's gravity.
I never get tired of seeing the rockets come in. It's very exciting, especially on the Mariner.
Now on land, a challenging cross-base transport lies ahead to the Atlas Spaceflight Operations Center. Inside this multifunctional facility, crews will remove the protective coverings, inspect the hardware, and install the final flight components. For now, this mission remains a go, but the highly complex job of stacking the rocket is still to come.